Good afternoon, everyone. Welcome back. It's been a while since I've recorded a video of any kind. So, a couple housekeeping things. I'm in college, and life is very busy. I'm not in classes right now, so I can make this video comfortably without having to worry about homework, whatever. But as we get back into the semester, in late August, uh, I'll probably have less videos out, and I don't even know how consistent I'm going to be now. But a couple things, I'm going to be using Tropical Tidbits, their website, or Levi Cowan's website, for all of the imagery that you see in my videos. So big shout out goes to him, Levi Cowan. He's an excellent meteorologist. He's working at the JTWC now, which is huge. Um, and so I really appreciate that. And yeah, I don't really have much else. So we're just going to be looking at a 92L today. This system is a mess, as expected, of a early season tropical cyclone. Not even a tropical cyclone yet, but you know. So we have ourselves a surface circulation right here that is kind of dragging itself to the southwest or west southwest. And this is going to be interacting with land for the next 36 hours, and or 18 to 36 hours, however long it decides to kind of stay parked here in this general vicinity, is going to determine how quickly it is able to organize as it drifts to the north, which is what we're worried about here when it comes up north later in the time frame for development. But there are a couple things that will likely hinder this thing from becoming super organized super quickly. There's not a ton of light shear in here. If you look at water vapor imagery, you can see this thing is getting ripped apart by a developing upper level feature here. And the reason that you're seeing a lot of convection right in here is because of that kink in the flow that is providing some upper level divergence, because the overall flow out of in the upper levels is due southeast. And so that little change in the flow is able to concentrate another vorticity maximum right here, which is fitting of a Central American gyre, which is what this is essentially. So you have two lobes. One is rotating up northeastward and is going to gradually kind of try to become vertical so that it can consolidate a little bit, and you'll see that on the model runs that we look at on the isobars for those model runs, but we'll get into that in a minute. And so this is getting torn apart right now, and this is in a convectively suppressive area. There's a lot of upper level convergence in this part of the jet because it's in I forget what it's called, but it's the exit region of the jet. The convergence in that region of the jet is causing convection to be suppressed in the area where the surface circulation is, and you're seeing showers develop, but nothing serious, or no serious convective development in this area. And this is in a much more favorable upper level environment for divergence, and this helps ventilate and bring up air parcels, and that is what we'll be talking about later in this video. But let's get into the upper level pattern here as this comes north. So still down here, you can see the kink in the flow and that little jump that the flow makes, and you have divergent flow over the Yucatan Peninsula, and this kind of translates into the convective blob that you're seeing here. And you can see there's lighter flow over the system, and you have the surface circulation is going to be anywhere in this general area. But you can see that there's a lot of ventilating flow around where the convection is. And if we translate this, let's go back. You can see there's a lot of convection just kind of messing around here. And As this continues northward, you can see there's still convection, and then whatever is left of the surface circulation is somewhere in here. And as we continue, you can see the gyre gradually consolidates. This is 48 hours, it's 7 a.m. on the 17th. You can see that there's now a closed isobar, but where is all the convection? It is on this side of the system, and that will remain the story for a couple of reasons. One, this is an early season tropical cyclone that is not going to have a very strong circulation to quickly tighten up. There's not going to be a lot of convective bursts over the system. So because it's probably bringing in a lot of dry air off of Mexico here, that is going to get wrapped into the system, as well as a couple other things. So as we get more into this pattern, you can see that surface circulation is right here. There's pretty light flow, but all this flow right here is divergent flow, what we talked about earlier. So there's going to be a lot of convection in this general area. This may be a little bit too much of a stretch here, but there will be forcing, upper level forcing, that will allow for convection to continue to fire and be very powerful convection due to the forcing in the atmosphere in the upper levels that will ventilate the convection and allow it to continue to really be very powerful for this time of year, really. And if we go forward in the GFS run, you can see that there is a low that eventually consolidates right here, but the convection is still displaced to the north and east, and you really have this kind of comma-shaped system with a drier side on the west right here with the dry air kind of wrapping around, and then it's not a lot of dry air. This is not going to have as much dry air as a typical early season system would, because it's still embedded in this very large moisture envelope that is with the, if you go back here, with associated with the gyre here. You don't really have a lot of dry air in this region, and this is all this moisture is being moved northward. And you don't really have any dry air coming off of Mexico. There's some drier air right in here, but not a lot. And that will continue to be the case. There's not a lot of dry air being forced into the system as we continue. You can see there's still westerly shear on the southern side, but as this moves northward, because now we're at hour 60 here, and you can see it's right here in the Gulf, and all that westerly shear is on the southern side, but you have flow out of this on the northern side that is divergent flow, which allows for convection. This is not going to organize. Let's get that straight. Even though it's in a more favorable environment, because of the upper level flow and the environment that it's going to be in, a broader convective mass does not translate into a more organized system. You want convection firing around the center of the system, and the center of the system is largely void of convection. And this continues to be the case. You can see as the system kind of gradually organizes here, it doesn't have a lot of rain around it. All the convection is on the northern side, and this is due to, if we go to 72 hours, all that divergent flow. You have this blob of convection that you saw on the precipitation map, and it is forced by this divergent flow aloft that is allowing for that convection, and this will stay. This environment will stay over the system for the entirety of its journey. You can see a little bit of westerly shear on the western side that may import some dry air off of the continental America or Mexico, and that may hinder it just a little bit. Again, there's not a lot of dry air, but as we go forward, you can see it's still a pretty sloppy system. You have the circulation center, which is still very broad, and then you have this very large fetch of moisture and kind of an area of concentrated deep convection. So this is not going to look super pretty. This is not a mid-season storm that, has all the organization and everything together. This is going to be a very messy system that looks maybe subtropical at times because you have, here's a circulation center, and then you have all this convection on the northeast side, and it'll likely have a subtropical look to it. And really, the GFS doesn't consolidate this until that divergent flow kind of disappears, and it's just left in a lighter shear region. This is 4 days out, though, so you can see that the forcing in the upper levels is not as strong, and it's kind of left in this generally light area of upper level flow. But it doesn't have enough time to really organize, and I don't think, and most of the models don't think, that this is going to have enough time and enough really favorable environmental conditions, because it is in a moist area, but this part of the Gulf isn't as warm as the Central Gulf, and so there's not going to be any sudden changes with this. Again, we're still 4 days out, and it's anyone's guess where this makes landfall, because the model spread is essentially from Corpus Christi all the way to the Panhandle of Florida. So that also brings up big questions about where exactly all the rainfall is going to be given the sloppy nature of the system, because as you can see here, that rainfall band kind of just sits over southern Louisiana for about a day and a half, and it continues to sit. Actually, if we go forward after landfall, there's not a lot of movement here from 92L or whatever it becomes, and so you get more rain over Louisiana, and this really depends. Where the rain happens really depends on where eventually the circulation center forms, because you have this very broad area of vorticity, or the large closed isobar right here. So the circulation could form anywhere right here, maybe up here. If it forms further north, then it'll come back further to the east. If it forms further south, then it'll be a little further to the west, because of where what dominant flow will be in place. I'm favoring something like more in the middle right in here. So it'll likely come into Louisiana or southeast Texas. But you have to keep watching this. And here's the rainfall forecast map from the WPC. Again, this blob of rain that you see, this very heavy rainfall area, could be shifted, 200 miles east or west, give or take 200 miles. And so if you're pretty much along any part of the northern Gulf Coast here, stretching from Matagorda Bay all the way to well west of the Tyndall Air Force Base in Florida, or well east, I don't know why I'd say that, you need to be watching for flash flooding, and especially if you're in southern Louisiana, because you've already gotten a lot of rain. And just be prepared for all hazards that a standard June mess of a system brings northward into the northern Gulf Coast. And if you want any historical example of what this could possibly maybe be like, think about Cristobal from last year and how it had that really weird presentation that was very sloppy. There was, the circulation center. Essentially, it was this, and then all this convection on the northern side, and then you had a fetch of moisture coming up north with it. And that is essentially what we're probably going to be looking at here, because regardless of how long it interacts with land, if we go back to the true color loop, it's not going to have as potent of a circulation as it does right now, because it is close to land. Even if it doesn't go ashore, it's still going to be, kind of dealing with land here. And it will go ashore, pretty much. It's already moving ashore right now, actually. So what we're going to be dealing with is a very messy system. This is not going to be something that is very powerful, but it will still cause a lot of problems because of the amount of rain and maybe a little bit of surge due to the length of the fetch of wind that you will see when this is moving north because of how the convection is oriented, blah, blah, blah. So it will still cause problems. Definitely if you're on the northern Gulf Coast, you need to be watching this, and especially if you're in Louisiana, given your troubles already with flash flooding, and it's only going to get worse from here. This is definitely not a welcome sign if you live in Louisiana. You don't want to be on that eastern side of the system, and you want to be ready for flash flooding. And please pay attention to your local weather offices and the National Hurricane Center for all the latest information on this system. And with that, have a good rest of your evening, and stay safe, and have a blast. See you around.